Section 1.3, Video 2, we're going to go through two shifted geometric examples where we do some long-run value work. The first example, like I said, a shifted geometric. It includes an added term to the geometric recursive rule. So it's almost like it's a geometric and arithmetic kind of at the same time. This example talks about trees at the nursery. There are lots of tree farms out there growing trees that get chopped down. They have different crops. So people have trees that they bring to their house to plant in their yard for landscaping when they want them. So here we go. The Forever Green Nursery owns 7,000 white pine trees. Each year, the nursery plans to sell 12% of its trees and plant 600 new ones. In every story problem, you should read it through twice. The Forever Green Nursery owns 7,000 white pine trees. Each year, the nursery plans to sell 12% of its trees and plant 600 new ones. So they want a recursive formula to model this situation. Well, let's think about it. The geometric part has to do with selling 12% of its trees, and then the arithmetic part has to do with planting 600 new ones. So remember, with geometric, let's change that. All right, with geometric, we're losing 12%, which means we're keeping 88%, and we'll write that as a 0.88. Please remember from the other day, when we write our geometric formulas, you always use how much you're going to keep. All right, so to get started here, geometric formulas have two parts. I'm going to use u sub 0 because we have 7,000 trees before we get started. We've bought this nursery, there's 7,000 trees there. Then what happens is we keep 88% or 0.88 of that previous number, and then we'll add 600 new ones each time. So that's what our shifted geometric recursive formula should look like. We should still have two parts, and then in the second part, there's a multiplication piece and an adding piece. So then you know to find in the first year how many trees you'll have, you'd plug that 7,000 into that u sub n minus 1. So it's shifted geometric because there's something adding or subtracting at the end. All right, unfortunately, in shifted geometrics, there's no really great shortcut to help you find the number of pine trees owned by the nursery after 10 years. This is where you just kind of have to plug and chug on your calculator. Here's 7 years, 8, 9, 10, and you'll have to keep going till you'll get your number at the 10th year. You know that 0th year, you're at 7,000. What I think I'll do is some calculator practice for the first couple, and then I'll ask you to pause the video to finish till you get all the way to 10. So what you'll do on your calculator is you'll start with that 7,000, and then you'll multiply it by the 0.88, just enter, and then you have to add 600 on the end. So it looks like after 1 year, it will have 6,760. So now that 6,760 is what we're going to plug in to our formula. So 6,760 times 0.88, then add 600, gets us to, what did it say, like 6,548.8. I understand you can't have 0.8 of a tree, but let's not round until the end. Let's just keep going because this is more of a mathematical exercise than a totally practical one. We're not actually at the tree nursery. And again, this is just giving us like an estimate. So keep going in your calculator. I'd ask you to pause the video now and then rejoin in just a couple of seconds, and I'll give you the answer for after 10 years. All right, when I did all the calculations, I don't think I'm going to bother writing all the years down, but for those of you that did choose to actually do the work and get to that 10th year, could anyone confirm 5,557 trees? Then the next question is asking is what is the long run value of the number of trees in the nursery? After 20 years of being in business or 50 years of being in business, how many trees are you going to kind of settle in at? It looks like there's a big drop those first couple of years, 7,000 down to 6,700, down to 6,500. After 10 years, we're sitting at 5,500. Now, you don't want your nursery to go down to zero, but it would be interesting to know where it levels out, where the long run value is, because as a business owner, you want to have enough that if you have to sell to people, maybe 1 year a lot more people want trees, so you want to make sure you have enough, but you don't want to have so much that it's too hard to maintain the land and the work that requires to go into them. So they're trying to find this little sweet spot, and where will this rule or this plan get them? So remember, the second part of our recursive formula was U sub n equals, it was, we keep 88%, 0.88 of the previous year's amount of trees, and then we added 600. Oh, there's that spot that goes crazy. Then long run value is when the previous year and the current year are the same. So we call them both x. Now I solve for x. So that gets me that 0.12, how much we lost. And then if I divide both sides, 600 divide by that 0.12, I get right around 5,000 trees. So over time, this tree nursery is going to level out at 5,000 trees in the long run. All right, one more example to go. This one, again, there's a lot of writing here. Do you need to write it all down? No. Should you write enough so when you look back to your notes, you can remember what the problem was about? Yes. And that answer will really look different for everybody, but take the time to do what you need to do to make your notes helpful to you later when you're studying for a test. All right, here, Jack and Abby are working at the community pool for the summer. They need to provide a shock or initial treatment of 450 grams of dry chlorine. Then they add 45 grams of chlorine each day after the initial treatment. Every day, the sun burns off 15% of the chlorine. Write a recursive formula to model this situation and find the amount of chlorine after 1, 2, and 3 days, and how much chlorine will there be in the long run. Because remember, that's what you really kind of care about for maintaining a pool, is in the long run, how much chlorine is there. I'm going to read it one more time a little faster. You should always do that in a story problem. Jack and Abby are working at the community pool for the summer. They need to provide a shock or initial treatment of 450 grams of dry chlorine. Then they add 45 grams of chlorine each day after the initial treatment. Every day the sun burns off 15% of the chlorine. Write a recursive formula to model the situation. Find the amount of chlorine after 1, 2, and 3 days, and how much chlorine will there be in the long run. All right, so looking here, let's start with the first part. It says write a recursive formula to model the situation. This is definitely going to be a shifted geometric because two things are happening. Is each day the sun burns off 15% of the chlorine, and then every day Jack and Abby add 45 more grams. So shifted geometric, where did it start? Really before anything got happening, the first thing they did was that shock or initial treatment of 450 grams. All right, and then the rule of what happens each day, well, how much do we lose? We lose 15%, which means we keep 85%. So remember, you always put what you keep. So we're gonna have a 0.85. We're gonna keep 85% of the previous days, and then they're gonna add 45 more each day. So that looks like a really nice recursive formula to me. All right, then to figure out what do they have after 1, 2, and 3 days. So I wanna know after 1 day what the value is, after 2 days what the value is, and after 3 days what the value is. So to start, you plug that 450 into the equation. So here's where your calculator will help. Let's see. So where were we? 0.85 times 450 and then plus 45 more. It looks after the first day, 427.5 grams. So that's going to be this data point right there. Okay, now we'll take that 425 and plug it into the equation again. So that 0.85, now we'll use 427.5. So 0.85 times 427.5, and then we added 45 more. 408.375 grams. I'm not going to round anything yet till the very end. All right, and then we have to go one more time to get the value on the third day. 7.5. So 0.85 times, what was it? 408.375 plus 45. 392 looks like. Oh, yep, I did something wrong right up there. I can see it. So 0.85 times it was 408.375. That should give me the number I was looking for, I hope. There it is, 392.11. All right, so after 3 days, I'm at 392.11. So there is the value. U sub 1 is 427.5. U sub 2 is 408.375, and U sub 3 is 392.11. So that answers the questions of the amounts after 1, 2, and 3 days. It looks like it's still going down by a lot, and it's asking how much chlorine will there be in the long run. Well, if I look at this graph, I can see the long run starts happening right out here. So if I had to make a guess, I'm going to say that long run value is about 300. According to that graph, it is. But let's quickly do the math, because it's not hard, to see if the algebra matches what the graph is telling us. So to find that long run value, what was our rule? We keep 85.85 of the previous amount, and then 45 gets added more. The current amount and the previous amount are considered the same in the long run value, so turn them both into x and solve for x. So I subtract that 0.85x. So I'm at 0.15x equals 45, and that gives me right around 300 grams, which is exactly what we were guessing on up here. So our long run value, I proved it algebraically and graphically looking at the graph, that in the long run, the chlorine will sit at about 300 grams. That is it for your videos for today for 1.3. If you have any bookwork to catch up on tonight, feel free to do so, but you'll get your 1.3 assignment to work on tomorrow in class, and hopefully have time to ask some questions if you have them. Have a great night. Thanks to you all.